Thank you to everyone for joining us today, and welcome to the second special session on national greenhouse gas inventories. So we do have a special guest from one of the Global Research Alliance's research partners, the Greenhouse Gas Management Institute, Dr. Olia Glade, who I will introduce soon. I just want to start off to remind everyone that we will be using the question and answer function as well as the chat function. So the question and answer function, you can open that from the bottom of your screen in Zoom, and you can note any question that you have as Olia is giving her presentation. And please all contribute to upvoting the questions that you think you would really like to have answered live, because we may have limited time for answering questions live. And then the chat function you can use to comment on things that are being said, or note any connection that you would like to make with one another as well. We've been seeing that in a couple of the other sessions. So yes, I would like to introduce Dr. Olia Glade, who I met through the Ministry of Primary Industries at New Zealand when she was the lead, the focal point for New Zealand's national greenhouse gas inventory. And I was working in the agriculture sector team. She is currently the Director for Measurement, Reporting and Verification Systems for Greenhouse Gas Management Institute. And she has extensive experience in greenhouse gas accounting, national inventory systems and institutional arrangements, as well as data management systems. And she's going to talk to us today about that, which is a topic that is extremely relevant for you all as Cliff grads, as you're all working in the science that underpins greenhouse gas accounting and national emission reporting. So without further ado, I will hand over to you, Olia. The floor is yours.
Thank you so much for the lovely introduction, Hazel. So I don't need to introduce myself anymore, but I want to say the warmest welcome to all the participants and big thank you for your interest in this topic and in greenhouse gas inventories. So again, without further ado, let me share the screen with you. And off we go. Right. Okay, so the topic today is national greenhouse gas inventories. So Hazel already introduced me, so I don't need to say that my name is Olia Glade. You already know that. And you also know that I work for Greenhouse Gas Management Institute. So today, I'd like to invite you into the realm of greenhouse gas inventory. And our ultimate goal today is to unveil the mystery of the inventory concept and look at it from the angle of practicality and usability for agricultural research specialists. We will begin from a definition of the inventory, its place within the global monitoring, reporting and verification process. Then we will have a look at the inventory composition and systems enabling and supporting it. We will also see how agriculture fits in, and then we will learn about the technical guidance for the inventory and general rules it follows. Finally, I will tell you a story of the future that shows evolution of the inventory framework development. Okay, let us begin. So generally speaking, the word inventory means a complete list of items, such as property, goods, stock, and the contents of buildings. It sounds boring. It becomes much less boring when it comes to inventories of greenhouse gases though. Greenhouse gases, or GHGs, are sitting on the shelves waiting for us to come and count them. It requires a lot of hardcore technical work and a bit of creativity to figure out how we can account for something that we can't even see and touch. And how would we see the limits for that kind of counting? So the idea of GHG inventories is that we are not counting the gases. We are estimating their emissions and removals using good theory and technology, organizational and human relationships, and clever software tools. So the inventory itself, in terms of greenhouse gases, is a complete account of emissions and removals of anthropogenic greenhouse gases resulting from economic activities within a national territory over a given period of time, and these are the annual estimates. The national inventory includes several issues, which are how emissions are estimated, what the results are, interpretation of the results, emissions trends over time, explanations and commentary. It also presents the main tool to connect mitigation with policy and establish emission reduction targets. It helps us to understand climate change scenarios, build emission projections, and envision what the future patterns in climate might be like. So the basic scope of the national inventories include direct gases like CO2, carbon dioxide, CH4, methane, nitrous oxide, N2O, and these three gases are most relevant to agriculture. In addition, inventory covers emissions of hydrofluorocarbons, perfluorocarbons, sulfur hexachloride, and nitrogen trifluoride. We are talking about anthropogenic emissions, of course, which means caused by humans. And those emissions are happening across all economic sectors. So here you can see the slide about greenhouse inventory within the monitoring, reporting, evaluation, and verification system. So the MRV system is a wide scope process that includes multiple actions, policy framework, and reporting, and global, regional, national, and subnational levels. We are speaking here about climate MRV because otherwise that kind of system framework can be applied to different areas of human activities. Each portion of the climate MRV can be considered as a system with the relevant rules, data communication, technological and regulatory guidelines. National climate MRV system structures, process and capacities are regulated by United Nations through United Nations Framework for Climate Change. Effective national MRV systems enable countries to determine their low-emission sustainable development goals and priorities, track their implementation, and identify the need for adjustment when the MRV shows that the actions are less effective than expected. Well, so as I mentioned, greenhouse gas inventory is an example of an MRV system. The inventory can be reported as a standalone product. Well, this is how the developed countries are doing it, or it can be it can be reported within the other products like national communications and biennial update reports. This is what most developing countries do, although some developing countries also publish their inventory as a separate document, which is really welcome. Regardless of the process included in the national GRADS inventory, we have some commonalities among the components of it. For example, each inventory contains measuring, observation, and data collection processes. For each inventory, you need to set institutional arrangement. For each inventory, you have to set QA and QA systems. And for each inventory, you have to set data management system to make sure of business continuity and robustness of the reports. As I mentioned, the developed countries are doing it in two different ways, annually in national inventory reports and every 4 years and every 2 years in the national communications and biennial reports. Developing countries report national communications and biennial update reports, which follow slightly different rules from the developed countries, but more about it later. So now we'll have a look at the key components of the inventories. They include institutional arrangements, that is, a system of agreements between agencies, organizations, and individuals to regulate inventory processes and deliverables. For example, This may include specific agreements on data provision, clearly identifying who has to provide data and information to whom, in what form and volume. It is a good idea to include here a mapping diagram showing relationships between inventory participants in relation to the inventory products. Here is an example of such diagram. Here we go. You can see suppliers of information, you can see organizational structure, and you can see resources. And you can see some agreements like memorandum of understanding or national laws that connect the suppliers of information and the organizational structures within the inventory realm. Now we will look at the institutional arrangements in depth. Like any other system, the inventory is not sustainable in the long run unless it has embedded organizational and regulatory mechanisms in place. Each step in the inventory process has to be well defined and agreed. In the past, many developing countries had run inventories as a part of their national communications and biannual report, biannual update report on ad hoc basis. Well, mostly overseas contractors have been used for that. So as a result, there was a disconnect between the inventories and there was no business continuity in the inventory process. For example, some people who were involved in the process 5-6 years ago, they were gone. There was no documentation left behind. There were no agreements left behind. So 5, 6, 7 years later, the new team has to start again from scratch. A lot of effort and information was lost in that process. So there was a disconnect between the inventories as there was no business continuity. The data were lost, as I mentioned, people moved. The national communications should be reported every 4 years. However, if there is no robust national system looking after the inventories and national communications would be reported at much longer intervals. Say to date, we're supposed to have 7 national communications produced if they are done every 4 years. But for many developing countries, 3, maximum 4 national communications have been produced. I think Mexico is a champion because they produced 5 national communications, which is really a good achievement. The situation gets even more frustrating when very good sectoral research and innovation, for example, in the agriculture sector or in the energy sector, are missed by the inventories produced by independent contractors. And relevant references are not included in the inventory reports. So that is why your expertise and knowledge will be most desirable in establishing and maintaining proper inventories. Now you can ask me, hang on, why are you talking about all inventories? We're agricultural specialists. Well, the reason why I'm doing that is that these processes and procedures and these structures, they're equally applicable for the national inventories across all sectors and across sectoral inventories. So every single bit of information I'm providing to you now is fully applicable to the agriculture sector inventory. That is, I'm really calling for your skills as researchers and analysts to apply this wealth of knowledge and experience and expertise to agricultural inventories. So to set up the institutional arrangements, you need to have legal basis. For example, Climate Change Response Act in New Zealand, or it could be a climate law or something like that. You will need management and coordination between inventory compliers and the approval bodies. That would provide for timely submission and timely movement of inventory report from a stage of production to the state of approval. Then we will need definitely to have an expert body of people who would produce the inventory data, process the data, make analysis, and also provide quality assurance and quality control of the inventories. And of course, last but not the least, we have data suppliers and data vendors, who definitely are very, very, very important to the inventories. Without them, there will be no inventory, because without that, we can't have it. So the institutional arrangements can be done in different ways. So this slide demonstrates different degrees of centralization in institutional setup making within the inventory continuum. On the left side, we have fully centralized approach, when a central inventory agency which produces the inventory itself and does final cross-sectoral analysis or the final sectoral analysis, receives the data from different organizations and does all the processing itself, and then produces the report. So on the opposite side of the spectrum, we have decentralized approach, where each sector inventory is produced in a totally independent manner. And the inventory central organization just collides it all together and sends the report to United Nations Framework for Climate Change. So you can see that in both situations, agricultural contribution and agricultural knowledge is essential to the healthy functioning of the inventories. Now I'm going to give you an example of the hybrid approach to institutional arrangements. And this example is very close to my and Hazel's hearts, because that is what we have in New Zealand. So that part of the picture on the left-hand side shows the structure or generalized structure of each inventory sector, which includes research groups providing the data methodology and enabling data processing and modeling. We have companies and business associations at different levels who are data vendors. We have also government agencies involved in data collection and processing. Those components, their efforts will result in the set of primary data and models for each sector, which will be submitted to sector leading agencies. For example, in New Zealand, such agency is Ministry of Private Industries. So at this point, the sectoral inventory is complete. And that complete inventory is submitted to the central inventory agency for sector level compilation and cross-sectoral analysis, domestic briefing and publications, and international publications and archiving. I want to show you another example, and that comes from India. And that example doesn't show the inventory arrangement per se, but it shows how inventory processes are working and which organizations are involved in those processes. So the head of the whole process is Ministry of Environment and Forestry. At this ministry, there is the project management cell, PMC, and that cell provides the overall guidance of the national inventory project and oversees and coordinates inventory process. So all the data for the inventory and emission factor and nationwide models are provided from the different groups of scientists and experts from institutions across the country. These institutions are part of energy, industry, agriculture, forestry, and base sectors. These include national research institutions, technical institutions, universities, industry associations, non-governmental organizations, and those belonging to private sector. So they submit the data back to Ministry of Environment and Forestry, technically speaking, the PMC. And after that, PMC produces the draft national inventory report. That report is going to for the peer review, which means quality assurance, to the working group, inventory working group, that also includes the experts from different inventory sectors. That group meets on a regular basis, about twice a year, and they perform the quality assurance for the inventory and quality control. So they produce the revised copy of the inventory, which goes for further feedback to technical consultations and also to the organization which is called NSC, which is National Steering Committee. So unlike technical consultations, steering committee is mostly policy and management organization, which looks at the inventory from policy and management point of view. Also, NSC reviews the inventory development process and recommends the improvements. So, both NSC and the technical consultations will produce the final inventory endorsement, which is sent for approval to the Cabinet of Ministers. So that's how the system in India operates. After we got ourselves familiar with inventory setting up in general inventory environment, let's have a look at inventory components. I already mentioned several times that there are several sectors involved in the inventory, and we have energy, industrial processes and product use, waste sector, agriculture sector, and land use change, and forestry, often referred to as forestry or follow. So often agriculture and LULUCF are considered together in the FLU sector. And here I portray different gases which I listed before. And on the left-hand side are our friends from agriculture. These are the ones we're reporting on. And on the right-hand side are the gases which are not emitted from agriculture, but they're emitted from IPPU. And of course, these three gases are emitted by other sectors as well. Apart from the sectors, we have inventory system, which is also described in the inventory report. And of course, we have cross-sectoral analysis, which compares and contrasts emissions, measures, and contributions from different categories, from different sectors. It analyzes uncertainty of inventories and works out the ways of inventory improvements. Apart from the gases in the sectors, there are other concepts in the inventory you have to be familiar with. And these are direct and indirect emissions of carbon dioxide and nitrous oxide. So for carbon dioxide, direct emissions are the ones where CO2 is directly coming from the process into the atmosphere. However, some other gases which are produced during economic activities, for example, methane, carbon monoxide, hydrocarbons, etc., they can be oxidized in the atmosphere. After that oxidation, CO2 is formed. So that CO2 is called indirect CO2. The same situation or similar situation occurs to nitrogen derivatives. Nitrogen is not necessarily emitted in the form of nitrous oxide. As you know very well, agriculture sector produces ammonia in various forms of nitrogen oxides, which can be deposited to the soils. And then after that, after the process in the soils, they can be transformed into nitrous oxide and then emitted in the form of indirect emissions. So now we are familiar with the systems, we are familiar with the components, we are familiar with the gases and different approach to the gases. This picture summarizes it all. So we have the sectors on the left, we have the cross-sector issues in the middle, and finally we have emissions inventory. Now I want you to have a look at the global picture of the emissions, because after all the inventories are submitted, the United Nations Secretariat and scientists working at IPCC can form a global picture of how our emissions behave over time. And here's the glimpse of this picture. So this is the timeline from 70s to 2010. That goes only to 2010 because that's a picture from IPCC, and that's the data point where the data were available from the entire world. So the picture shows emissions by sector. And the yellow is CO2 from fossil fuels and industrial processes. The orange is also CO2, but this time from agriculture and follow. The blue lines and blue areas are emissions from methane and nitrous oxide, and the dark line and areas on the top shows fluorinated gases. So you can see that for all gases, we have a trend of emissions increasing. It's the highest for CO2 from fossil fuels and industrial processes. However, you can see some increases in emissions of methane and nitrous oxide as well. Of course, people want to eat, and we have growing population, we have growing demand. So agriculture feeds the world, and that's why emissions are growing. And here is a picture of a balloon which has 1 ton of carbon dioxide. This is just for the sense of scale. You see that balloon is much bigger than 1 car. And the units that we are using for emissions in this graph are actually quite high. They're gigatons CO2 equivalent. And gigatons are billions of tons of CO2. Right. This is just another way of looking at the global emissions. This is a little bit newer data, so the percentages in this picture might be slightly different from the previous one, but the idea is the same. So we have the biggest amount of emissions of carbon dioxide, mostly coming from industry and energy. We have land use in agriculture producing the biggest amount of methane nitrous oxide. We have waste sector, which is the smallest among the sectors, and it produces also methane, nitrous oxide, and carbon dioxide in small amounts. Now, this picture is something that you all will be interested in. I built it especially for you. I downloaded the list of the countries of our webinar participants. Here it is. And for each country, I portrayed the total emissions from greenhouse gas emissions from the national inventory, and that excludes forestry, so just emitters, no removals. And these units are in gigatons. Now these bars show the proportion of agricultural emissions to the total national GHG emissions. And you can see they're very different for different countries. So you can find your country here and see how you fare. Now we move to the next step. We already know that the inventory system is quite complex. It has lots of data and information, and we're really, really interested to keep that information well maintained, well presented, and well systematized. To help this, we need to establish the data support or data management system. In this picture, I presented the model of agriculture information management system, which includes the system of subsystems looking after data collection, institutional arrangements, quality assurance, quality control, data processing, emissions trends, uncertainties, and key category analysis. So each of those little bits can be a system on its own. It can be based in such simple platforms as Excel or Access. It can be even paper-based. As long as it is experiencing systemic approach, it's good enough for us. Now, of course, all of this can be presented within one system. For example, Australia has that, but that is extremely expensive, unfortunately. They spend $500,000 1,000 Australian dollars, which is almost the same as American dollar, just for maintenance of the system per year. So maybe it is more sustainable to have different components of agricultural system sitting in different applications or different subsystems. Right. Here I give you the general systemic picture for data management systems. And as I mentioned before, it doesn't have to be a one software application. It could be even paper-based systems. So here I identified the major system components you have to keep in, to take into account when you're designing, building, or acquiring the system for agricultural sector. So those components, of course, include things like boundary, system boundary, that pretty much describes everything that is related to the system purpose. So if you know the system purpose, we are like 50% in. In this particular example, data collection, raw data, and preliminary data processing are not within the system boundaries, but they can be if we define them that way. System outputs are also coming outside the boundaries, and again, these are things which could be within if we define it that way. Those arrows show system communications. It could be with the users or it could be with the other systems. Now within the system, we have input, output, interface. The interface is sitting on the boundary. That's what you see as the users or what you communicate with. Within the system, we have the system platform. It's what it is based on. It could be, as I said, paper-based, could be Excel, could be Access, could be some, PHP, could be something else. We have storage facility. That storage facility is absolute must, whichever way it's done, but it has to be very systemic and consistent. The storage facility produces the inputs to the data processing engine. And again, it could be manual or it could be semi-automated, could be fully automated. Data processing also requires data analysis, which also produces outputs. The outputs also have to be stored in dedicated storage facility. So that's the picture of data management system that you should be aware of. Right. Now, here's an example of a data management system which is dedicated to agriculture sector and land use. That is a wonderful system designed and developed by the Colorado State University, very well accepted by agricultural specialists and inventory around the world. So the system allows to enter activity data. It has inbuilt quality control procedure, doesn't let you make a mistake. It calculates the inventory, allows to enter your own emission factor or use default emission factor. It is fully compliant with the inventory guidelines, and the best thing, it is free. So you can use that link and you can request the copy of the tool and then enjoy using it. So another set of examples includes templates for recording the institutional arrangements for the inventories. They can be also adjusted for the agriculture inventory systems. So they are designed by US EPA, Environmental Protection Authority, and these are the links where you can get those templates for free. They can be copied into Excel and modified to your heart desire. Now let's have a look at the rules that govern the inventory producing, reporting, etc. So we have two sets of rules. One is a policy framework, which is provided by United Nations Framework Commission for Climate Change, Convention, for Climate Change. They produce reporting guidelines for the inventories. And we also have the methodological framework for the inventories. Current one is 2006 IPCC guidelines. we'll start from a deeper diving into methodological guidelines, because that is probably closer to your heart. So these are the cornerstone work for all GHD inventories. The guidelines, they are designed and developed by thousands and thousands of scientists around the world. Every country contributes to that. Those scientists, they do very thorough reviews of scientific and technological achievements in each inventory sector. And based on those achievements, they design and develop the methods that are recommended for inventory calculations. They also provide default emission factors, which is also very important. For that wonderful work, the IPCC has been awarded a Nobel Prize, which is a gold standard itself. So the information on agricultural sector can be found in volume 4 of those guidelines. And you can find all default emission factors for agricultural sector in the same volume. And this part of the picture, I included the evolution of the guidelines to show you that they are not static. They keep being updated. And the current version we are using is the ones which are 2006 guidelines. However, 2019 refinement is already produced. The only reason why it is not included in this picture is because it is not adopted by Conference of Parties yet. Once it's adopted, it will be the formal go-to data source, the guidance source for everyone. Hopefully it will happen soon. Right, here is just, I summed the links to each of the volumes. And on the left-hand side, you will see also very useful links to the guidelines themselves and to the refinement and to another tool, which is really very useful. This is emission factor database, where you can find not just default, but also country-specific emission factors provided by researchers and analysts from around the world. Another tool from IPCC guidelines that I strongly recommend you to have a look at are the worksheets, which allow you to, which help you to calculate emissions from different categories. Now we will move to the political framework for the inventories. This slide shows the history of MRV in the UNFCCC process for non-Annex 1 countries. I understand that most of the participants today are from non-Annex countries, so that's why I put this on the map. You can see that everything began from UNFCCC adopting and entering the force, the first UNFCCC agreements. So in 1996, the first guidelines for national communications for non-Annex parties were developed, and first national communications were submitted in 1997. Then the consultative group of experts has been established, and that group was doing the quality assurance for the inventories submitted by non-Annex parties within the national communications. In 2002, the current national communication guidelines for for non-Annex 1 parties have been established. And in 2007, they were extended for national adaptation reports as well. So they became measurable and verifiable. 2010 is a big milestone signified by Cancun Agreement, which included introduction of biennial update reports and international climate consulting assessment, RED+, etc. In 2011, the Durban platform has been developed, and that platform provided the guidance for biennial update reports and international consulting process. And of course, the first BURs have been submitted by the end of 2013, which is really good. In 2013, the guidelines for domestic MRV and national adaptation and national mitigation adaptation reports were established. And finally, in 2015, we have a huge milestone, which signified shifting to totally different track in reporting on climate change. That was the Paris Agreement. All countries will now submit national determined contributions. They will submit national inventories within the same rule track, within biennial transparency reports, and also greenhouse gas inventories if the countries wish so. So let's move on from that. More about Paris Agreement. So the key things in Paris Agreement was strengthening the global response to the threat of climate change. So the long-term temperature goal associated with that attempt is 2 degrees, below 2 degrees. And countries will make their best effort to push it down to 1.5 degrees. So the Paris Agreement also established enhanced transparency framework. The previous reporting was done under simply transparency framework. So enhanced transparency framework means robust transparency and accounting system, and, which is very, very important, each party will undergo the international technical expert review. Unfortunately, until now, the national communications and therefore inventories submitted with the national communications for non-annexed parties were not reviewed. And that created some challenges for ongoing improvement of those parties and growing understanding of methodology behind different sectors. In this slide, I put together the key differences in reporting and review and analysis for different systems. This is existing transparency system. This is what is going to happen in the future. So it's our story of the future. So within the existing systems, we have separation between Annex 1 countries and non-Annex 1 countries. The biggest difference between the two is different rules. Apart from different reports, we have national communications submitted by both, but Annex 1 parties have biennial reports, national inventories. Non-Annex parties have a biennial update reports. In terms of analysis and verification, we have a framework for rigorous review of Annex 1 party submissions and much less rigorous review of non-Annex 1 party submissions. For example, national communications for non-Annex parties are not reviewed. And there is technical analysis of BURs, but it's not as rigorous as it should be if we speak about moving into the future. Facilitative sharing of views is a good system of international questions and answers at SAPSA meetings or COPs, and that trend will continue in the future. So now let's see what is expecting us from 2024. First of all, we don't speak about Annex 1, non-Annex anymore. We have developed countries, developing countries. It's not a secret. People have different needs and different capacities. So the system will make the best effort to help developing countries to fulfill their needs and improve their capacities. So national communications, as before, will be still published every 4 years. However, the focus is shifting to biennial transparency reports, BTRs, which will be obviously published every 2 years. It means a huge difference for developing countries because now there is a big incentive to have better business continuity for inventory reporting and establishing permanent systems responsible for the reporting and the project associated with data collection and processing. The national greenhouse gas reports from developed countries still will be submitted on an annual basis. A big change occurs in terms of the analysis and verification of the reports. So there will be technical expert review of all VTRs, not only developed countries. And there will be also multilateral facility of consideration of progress, FMCP, which will be including not just the BTRs, but also national determined contributions and the progress of made towards the targets established in those contributions. There will be also annual review of national greenhouse gas inventories for developed countries. Now, I told you before that both developed and developing countries will be following the same set of guidelines in the future. However, to recognize that there are different needs and capacities in developing countries, there is a flexibility provided in the guidelines. So all countries will be doing key category analysis, but certain flexibilities will be allowed for developing countries. The same thing for tier 1, tier 2, tier 3 calculations. There will be flexibility for the developing countries because high tier methodologies mean higher relevance of methodologies to the country, but also high complexity. There will be the same flexibility or similar applied to time series, including the base year for the inventories. And the same goes for quantitative, qualitative uncertainty analysis, significance, threshold for completeness, meaning beyond which point we say the emissions are not so significant, so we don't have to look in depth into them, quality assurance and quality control. So for all parties from 2024, assessment report 5 of IPCC will be used to get the global warming potentials for different gases. As for the guidelines from methodological point of view, we will be using 2006 guidelines, and if 2019 guidelines are adopted by the COP, then they will be also used here. So for sectors and gases, all countries will report on energy, IPPU, agriculture, and LULUCF separately, and waste. The gases involved will be CO2, CH4, N2O, HFCs, PFCs, SF6. For NF3, there will be flexibility. The indirect CO2 emissions are encouraged for reporting, but not mandatory. Also, parties will indicate if natural disturbances in totals are involved. And of course, there will be some additional guidance on approaching HWP, and that is the harvested wood products, how they're reported by the inventories. So all these flexibilities are not given for granted. They are provided in the modalities and program guidance for those developing country parties that need it in light of their capacities. So the countries are encouraged to report as much as possible, as much as they can. If they can't do something, that's all right, but there will be projects run to ensure that the capacity grows and more and better can be reported next time. So for now, you could ask me, where can you find more details about that guidance for enhanced transparency framework? And that's the answer to that question. The ETF guidance at the moment is published in the form of frequently asked questions at the United Nations Secretariat website. Here is the link to that document, and here's a list of topics covered in the document. So the spectrum of the document is quite wide. We have transition to reporting from BUR to BTRs. We have linkages between NDCs and enhanced transparency framework. We have linkages between national communications reporting and the enhanced transparency framework. We have a specific section on the inventories and specific sections on BTR. We have also section cross-cutting issues and flexibility provided for this issue reporting. We have the technical expert review section, which is really useful for everyone. We have section on institutional arrangement and support that global green funds and other funds operated under United Nations and in conjunction with United Nations could provide to establish institutional arrangements. We have section on training and tools, and we also have section for parties which are not party to Paris Agreement, how they report. That's where you learn. Okay, so that's what I wanted to tell you, and that completes my presentation today. So this is time now for you to ask your questions and write your comments. I give you the floor. Thank you very much for your attention, and my huge thanks to Global Research Alliance for allowing me to present this information to you. It's been a pleasure. Thank you.
Thank you so much, Olia. That was fantastic. I learned a lot myself and have already been involved in this for a while. So thank you. It was really great. We have got quite a few questions come through already, actually. So I'll start off with one from Adnan Ashad, who is from Pakistan, I believe, from memory. So he's asked how the Cliff Grads can ensure that their data that they're collecting through their research is relevant for national inventories and how they can avoid data gaps.
Okay, great question. I really want you on my expert review team. Right. So, excellent question, actually quite a few questions here. First of all, to be aware, to make sure that you're providing the data in the right form and the data are not missing, it's a good idea to have a look at the methodological guidelines for agriculture, because they will provide you with the knowledge on the methods, formats, and requirements on data collection and data processing for the agriculture sector. And they will also give you an idea how to fill in the gaps in the data if you have them. So that's my advice. Have a look at volume 4 of the IPCC guidelines. My other advice is contact your focal point, national focal point for UNFCCC, and ask them to enroll you for the studies for agricultural experts on IPCC guidelines. These studies are really very good. Greenhouse Gas Management Institute provides the platform for that, but people who are enrolled through United Nations Framework for Climate Change, they are doing the study for free. So I strongly recommend people to attend those courses. I know quite a few world experts who did it and who were very happy about it. I myself did it too. So that's the other one. So that's that question. Can I move to the next one? Because I can see that the question for Mudabuchi Iboka, is that correct?
Yes, correct. Yeah.
Thank you. Right. So the question is there any penalty if a country fails to submit her BR or BUR? Well, that's a good question. But the thing is, we're not speaking about penalties here. We are talking about countries who are signatories to the international agreements. So if the country signed the agreement, thereby the country promises the entire world that they will be doing those submissions. Breaching this, this promise means that the country does not fulfill its international obligation. So politically, it's not a good look at all. And developing countries are not punished in a monetary way for not submission, but by not submitting, they're punishing themselves because it means their data are not seen by others. There is no way feedback can be obtained. There is no way people can learn through the current agreements. Also, the greenhouse gas inventories, which are included in BURs, and national communications are the only way for developing countries to provide the platform for developing national projections, national policy scenarios, national mitigation scenarios, to name a few. So it's in the best interest to produce good quality inventories and provide them timely, so the data are not outdated. Right, so next question from the same person. Also, are there measures to ensure that countries, especially among the major emitters, do not underreport their emissions? Oh, yes. So the biggest emitters in the world are China on the top of it, United States of America, European Union, then we go to Indonesia, and then we go to India, and then we go to European countries like Germany, France, Great Britain, etc. So for developed countries, there is a very rigorous review process, which is looking just at this, that countries provide the complete estimate, complete account of greenhouse gases. Complete means neither accurate, complete and accurate. So that means there is no underestimation and no overestimation of the emissions. To make sure that all categories are covered, the threshold for emissions is introduced, the threshold of significance, and also the categories for inventories which are explained and described in the IPCC guidelines with emission factors, default emission factors provided. Those are the mandatory categories. So if emissions are not provided for those mandatory categories, the countries are given a good feedback for that, saying, please re-estimate them, recalculate them, please provide appropriate estimate. So for developing countries, as I said, there is no such rigorous mechanism yet, but there will be one once we move to enhanced transparency framework, and that will work the same way. The reviewers will provide a technical analysis of the submission, compare the methods and the initial factors with those provided in methodological guidelines, check the country's explanations and interpretations of their data, check the methods and model description to make sure that it's all transparent and indeed leads to the accurate estimation of emissions. So that's how it is done. Right, next question, Winnie Nanyar, Kenya. So great presentation, thank you. Is there a way to estimate nitrous oxide emissions from nitrogen fertilizer applied where chamber measurements are not available? I think I will address that question to the agricultural specialists, and maybe Hazel, you would answer that question.
Yes. Is there a way to estimate nitrous oxide emissions from nitrogen fertilizer applied where chamber measurements are not available? I probably don't feel comfortable answering that question, but we will have a session in 1 week's time on pasture systems and agronomy, and we will have Dr. Jacobo from SIAT there, and he would be able to answer that question well. So I would encourage you, Winnie, to ask that question again in a week's time.
Yes, and right here, I think both Hazel and I illustrated a key principle of learning, especially in the inventory space. There is no, well, the only stupid question you can ask is the one you haven't asked. That's one thing. And the other thing, which is also very important, is, okay, I can't answer it now. I will do my best to find the answer. So every time when you don't know the answer to the question, it's an incentive for you to learn more and to go and ask other people. So I honestly don't know the answer to that question, but there are people who do. And I actually make it a point for myself to find it out. So by tomorrow or by the after tomorrow, I will know the answer. Okay, next one. How do we understand uncertainty in greenhouse gas emission inventory? Excellent question, thank you for that. So uncertainty comes from the normal statistical definition of uncertainty. So what it means is, for example, you have a certain parameter, like emissions from certain amount of activity data. You can look at the value of that parameter in several different experiments or in different years, etc. Or several times you could estimate emissions from the same mechanism or from the same animal or from the same group of animals, etc. Every single time when you're applying the same conditions to the experiment using the same methodology, the same equipment, you will have slightly different results, which means there is no one value that would describe that, say, greenhouse gas emission. So what you do is you will estimate the average or the mean of all those experiments, and then you will see how the results of each particular experiment differ from that mean. So you will have the deviation from the mean. Then you calculate the standard deviation for those, which uses the square root of the sum of squares approach. And then using that standard deviation and the mean, you will have the uncertainty. The uncertainty will be plus minus standard deviation square. So that is what uncertainty means for each particular measurement. Now, there is another way to describe uncertainty of the inventory, because you have many measurements, have many categories, many sectors. What do we do with those? For that, there are two different methods to calculate the total uncertainty of the inventory. So one method is propagation of uncertainty, when you use the two-dimensional Pythagoras approach. Like uncertainty of each particular category is calculated as a square root of sum of two squares. One comes from emission factor uncertainty, one comes from activity data uncertainty. Each of those can be determined just the way I described before, from the experiments or from expert judgment. So once you had this square root of sum of squares, you can estimate how does it relate to the total emission estimates. And then you can add all of those values weighted through the total emission estimates values together. That's how you propagate the uncertainty and achieve the total emission uncertainty for the inventory. That's one method. The other method is Monte Carlo method, which is requiring the specific software, and it's going for goodness of fit approach for the uncertainties until you match the best uncertainties description for each component of the inventory of each sector, each category. This method is also applicable to specific sectors and categories when you have some time dependencies or you have some big data discrepancies, etc. In the agriculture sector, in many categories, Monte Carlo method used instead of propagation to have the uncertainty over a group of categories. Right, so I hope I answered that one.
Yeah, I think that was great, Olia. Perhaps you could expand a little on how to reduce uncertainty as well.
Sure. So one of the ways for improvement of inventory quality is the way to reduce uncertainty. And here you can see several ways straight away just from the mathematical approach I described. Since both emission factors and activity data provide the contributions to those uncertainty, improving the quality of activity data, meaning improving the conditions under which activity data are collected, improving the quality of equipment, improving the number of experiments or number of data points would definitely reduce the uncertainty from activity data. You can use the improvements, technological and scientific improvements, to measure things better. From emission factor, it's the same thing. You will use the best available emission factors most suitable to your country, to specific farm, to specific category, to specific region. Make sure that you have taken into account climatic zones, the altitude at which the activity occurs, because they could have different emission factors. So the more specified the data is, the more specific emission factor you apply, the less uncertainty, the lower uncertainty you will have for that. The other way to reduce uncertainty is to enable consistency in monitoring of the data collection and reporting. Because consistent systemic approach, good software applications would help you to provide less spread between the data points. And of course, the regular calibration of any equipment you're using would also reduce the uncertainty which comes into the experiment from the measurement itself, from the method of measurement. Well, did I cover it?
Yes, thank you.
Great. Right, so, okay, what's the next one? Right. Okay, as I understood, the emissions calculations for national inventory is within country boundaries. What about imported products? Are those counted for the producers or end users? Wow, I love you guys, you're so smart. Excellent question. So, yes, indeed, the inventories are done on the geographical boundaries, that is agreement in the world. So each country is responsible for emissions which happen on this territory. Whether it comes from imported products or domestic products doesn't matter. If it happens on your territory, that's yours. It's like what happens in my house is my responsibility. That's how it works. There is some additional rule for that, but it's not related to agriculture sector. It is related to the energy sector, specifically international transport, like international aviation and international navigation. In this case, the country is responsible for emissions of fuels which are supplied by that country at the port or the airport from where the flight or navigation started. So for example, if you're flying with, I don't know, American Airlines from Washington, Washington, DC to Wellington, New Zealand, America will be responsible for the emissions. But if the same airline flies from Wellington to Washington, DC, that's New Zealand who will be responsible. And those emissions are not added to the national totals, they're reported as memo items. So you can find the data, but they are not just added up to the national emissions. In the agricultural sector, as I mentioned, we don't have that arrangement, there is no problem. Right, so what else? How those imports, exports can be reflected in the inventories. Technically, inventories, national inventories in agricultural sector don't use that approach. Approach where we have imports, exports, the domestic use, consumption, etc., is applied in industrial processes and product use for mass balance, and it is also applied in energy sector. However, just a few days ago, I completed the review of the publication submitted to Carbon Management Journal. And in that publication, a very interesting concept has been explored in relation to the national emission reduction targets. And that has been explored from input-output perspectives, where the amount of imported products was considered as imported emissions, and the amount of exported products was considered as amount of exported emissions. There was a very complex mathematics involved with matrix analysis, which took me a while to crack, but I did. But if you're interested, have a look at input-output tables online. And you will see examples. Some examples were done in Great Britain, others in Korea, South Korea, but that approach has been applied to the national greenhouse gas emissions. Right, so next question. Oh my God, having a comprehensive pattern trend of emissions is quite critical to policy making and mitigation strategies. Is there any model that could be used to simulate GHG emissions data of lost years in situations where there is limited stored data, as is usually observed in developing countries? Thank you. Love the question. Guys, we can have another hour for questions, I don't mind.
Yeah.
Okay, so yes, indeed. So those techniques are called splicing techniques, and they are well described in volume 1 of IPCC guidelines. I think it is chapter 3, I think, right? Or chapter 6, gosh. I can't remember which chapter, but I remember about those techniques. So there are several techniques available. One or two of them are based on the same mathematical principle, and they're called extrapolation and interpolation. So by the name, extrapolation means that you have certain amount of data points, but for example, you don't have the data from a long time ago. In this case, if first thing to do is to check if the data points you do have fall within reasonable range in a linear pattern. If you have more or less linear pattern, you can work out the equation of the line using linear regression, for instance, or the trend from Excel. You can calculate the equation for those data points that you do have and use the same equation to work out the values for the data that you don't have. It is exactly the same approach if you have a few data points missing in the middle of the time series. So again, check first if the data are following a linear pattern. In this case, use the linear regression and calculate the linear trend across the entire time series to find out what the missing points are. Of course, in the next years, I recommend to run special projects that would actually investigate what the data points might have been on those missing years and improve the inventory time sets. Now you can ask me, what if they are not linear? Well, in this case, have a look if there is some other pattern, say logarithmic or exponential or something else, would fit the existing data points and use that equation. That will be a much more complex mathematical exercise, but if you need it, you can use it. So these are only two techniques, but there are more. So there is another technique which is called overlap. And the overlap technique is used when you say for 10 years of the inventory, you had enough data to use only tier 1 method, the simplest possible method with default emission factors. And for the past, say, 6 years, you could have enough data to run more sophisticated method, tier 2, with country-specific parameters. And between those 10 and those 6, we have still, say, 3 years when we could have both tier 1 and tier 2. What you're interested in is to obtain more sort of updated tier 2 or tier 2 values for the previous 7 years, which were not covered by the tier 2 method. So overlap method allows you to do that. What you do is you will calculate the emissions using the tier 2 approach for all available years. Then you will compare the data where the tier 2 method can be applied and tier 1 method still can be applied. So in this example, we have 3 years of that overlap. Next thing you do is you have the ratio between the amounts obtained through tier 2 method and amounts obtained through tier 1 method. Check if those ratios are more or less the same. you can use the standard deviation for that group of data to see whether they fit reasonable, with a small interval. If they do, you calculate the average of those ratios and use that average value as the proxy emission factor for the data going backwards for the first 7 data points. And then you multiply the existing data in those 7 data points by this proxy emission factor, and you will obtain updated time series from the beginning to the end. Now, of course, it's not always the case that the ratios between different methods work, or you have linear patterns and you still have missing data. What do you do then? There is still a method to help that as well. That method is called surrogate method. And in this method, what you do is you have to perform very good analysis of the data sets in the country that have a potential to follow the same, to have the same behavior, to follow the same pattern as your greenhouse gas emissions. For example, the mileage traveled by cars more or less coincides with the energy consumption from the fuels used for the same cars. So you can see that, okay, if I have that pattern, I can use that pattern as the equation to calculate the missing data points. Now, if you don't have that, I'm going for all possible lengths. If you don't have that, then it's a good idea to have a look at other countries' reports, especially the countries with similar national circumstances. And when I say national circumstances, say for agriculture sector, it could be similar climatic conditions, similar soil types, a similar, say, animal types for livestock, a similar livestock management approaches. So you could have a look what the emission patterns they experience and then scale their pattern to your country using the data points that you do have. Of course, it's extremely uncertain. It's extremely inaccurate, but it's better than nothing. And in the next years, you might be able to improve those sets. All right. Okay. Next question. Oh, thank you for your compliment. So, are national inventories unique for a particular country or general across countries? If unique, how does data from research findings fits into it? Okay, I wouldn't say they are completely unique. They're produced by different groups of people in different countries under different circumstances, but they are not unique in terms of unique approach, in terms of uniform approach to the methodology of the inventories, since they all follow the same rules and the same guidelines in terms of methods, like how you calculate emissions from the cows, for instance. Then in that sense, you can compare the different inventories, you can compare the results. Also, each country is strongly encouraged and actually required for annexant parties to provide detailed explanation and the properties associated with activity data. So you will see what, say, the average mass of the cows was for the cows involved in the calculation, or what type of use there were for the calculations of emissions from sheep, etc. So in that sense, the better you follow the guidelines, the more comparable your results are. And in fact, one of the principles for the quality of the inventories is comparability between different inventories from different countries. So that is why we can learn from each other's experience, and we can apply research produced by one country by the other country, as long as that research is well described and well understood. In fact, both Hazel and I are involved, or will be involved soon, in a wonderful project which will be describing, which will be publishing the summary of improvements in inventory in agricultural inventory coming from different inventories. Once it will be published, I strongly recommend you to have a look at it. You will find lots of interesting things there.
I was hoping you might mention that.
Right. Okay, next question. What are your thoughts on completing GHD accounting on a traditionally used 100 years GWP compared to GWP star, especially with keeping in mind the goal of limiting global temperature increases to 1.5. Okay, so global GWP, for those who don't know, stands for global warming potential. And those are the coefficients which compare the radiative force of different greenhouse gases. And the radiative force is the physical ability of the molecule of the greenhouse gas to absorb and then reflect back the infrared radiation received from the Earth's surface or from heating. So that's what it is. And there are several different sets of global warming potentials which keep being improved by IPCC. So currently we use assessment report 4 set of global warming potentials, which is 100-year horizon. So for the 2024 reporting and beyond, so far the word is that we will be using global warming potentials, not GTPs, not global thermal potentials, but global warming potentials with 100 years horizon, but coming from assessment report 5 of IPCC. So that's what it is. And yes, that can change because there are school of thought that global thermal potential might be more applicable as we develop further. But that time didn't come yet. The other thing which we have to be aware of is the baskets of gases for reporting. There were huge discussions about it, starting from the first conferences of parties, and still there are ideas that we probably should distinguish biogenic, non-biogenic emissions for methane, for instance. Especially we can identify the concentrations of biogenic methane using carbon isotope method from the atmosphere. So, well, as soon as those analysis in research equipment and research facilities will be available to all countries, we probably will be able to switch to that. But until all countries have fair access to those facilities, we can't require everyone to do what they can't do. So we go with the smallest common denominator to make sure we have a fair approach for accounting and reporting for greenhouse gases. Right, now due to power outages, there tends to be increased use of firewood for cooking, even in urban areas. How is this treated in terms of its contribution to national emissions? Oh my God, another good question. Right, I had just recently a conversation about it with someone else, and here it is. Think about it. There are two approaches to thinking about it. Approach number one, which is currently applied. Technically, burning wood means that you're using the material which during its growth was absorbing carbon dioxide from the atmosphere. When you burn it, because of the law of conservation of mass, the exact same amount of carbon dioxide will be released. So the net amount of carbon dioxide change in the atmosphere because of that burning is zero. That is why those emissions from wood, carbon dioxide from burning wood, are not added to the national totals, although they are recorded as carbon dioxide emissions from combustion of biomass. You can find those values in the energy sector NEMA items. Right, Now, from the other perspective, and well, I actually like the other one. Yes, it's not in the inventory, but on the other hand, the tree doesn't grow in 1 second. You burn it fast, but it takes 25 or sometimes 50, sometimes 100 years for the tree to grow. So personally, I probably wouldn't burn trees for fuel, and I would try to avoid it. We destroy quite a lot of forests for the industry needs, for other needs, for building, for construction, etc. Let's just not increase the problem by burning just for the sake of burning. Let's just be very, very careful how we treat our environment and don't take it for granted. So, but that's my personal view. Don't take it as official view. Right. Okay. I can see just one more question. Right. I would like to know which is the best way to calculate into all emissions across the time. I mean, I have data collected for each week, but I want to know for the entire growing season. How is the best way to obtain this data to achieve the entire growing season accumulated emissions? Okay, so you will need to do cumulative calculation rather than individual data points to obtain the total emissions over the annual time period. So cumulative value means you just keep adding them together as you obtain. If you have some data missing, then you have to analyze which circumstances were, what situation was there for the data when it was missing. For example, was there any difference between that week and the weeks preceding it and weeks following it? If there was no big difference, then you can average and interpolate the data for the missing data points. If there was a big difference, then you need to do additional research project. You can ask for expert judgment from the people who were involved in similar situations from your country or the other country. So that would be my approach.
Yeah. So Melissa, I would also encourage you to ask that question in the session next week with Dr. Jacobo. Yes, and we have had one more question come through, but we've only got another couple of minutes. Your question, Raphael, about the MRV system is developed and implemented in the livestock sector. We actually have a special session with Dr. Andreas Wilk specifically on livestock MRV, and that is in 2 weeks' time. So perhaps we save that question for that session. The lights are just gone out. But Olia, if I may take liberties as the chair for this session and ask you sort of a closing question for all of the Cliff Grads. Do you have any advice for them in how they can connect with the governing bodies for their national greenhouse gas inventories and how they can ensure moving forwards in their career that their science is being connected with their inventories?
Right, good question. Each country that develops the inventory or national communications, biennial data reports, etc., have a person who is called national focal point for UNFCCC. When I say UNFCCC, I mean UNFCCC, right? So these people are your go-to people to find out how to connect to the inventory realm if you want to be connected to that realm. In most countries, in my experience, those people are located around Ministry of the Environment or Ministry of the Environment and Forestry, or for example, Agriculture and Environment, but something with environment. Sometimes it's Ministry for Energy. And some countries have the Climate Change Commission or something like that. So that would be the most likely organizations to go. If you don't know who they are, it also is a good idea to have a look online at UNFCCC website, and the website is unfccc.int. That website has a database for experts, nominated experts by different countries, including people from agriculture, from different sectors, and generalists. That database has also the focal points for each country. So that's where you can get the contact details for them. If for some reason that person is listed in a database, but say the data is outdated, the person's not doing it anymore, you still can write to that person and they might be able to tell you who to connect with. So that's an option.
Yeah, thank you so much, Olia. That was really, really good advice. And thank you so much for answering all of these questions today. As you can see, the Cliff Grads are really quite interested in this topic and is very, very relevant for them. We truly appreciate you sharing your expertise with us. It's been really fantastic, so thank you.
Thank you. Thank you for inviting me in. Dear guys, I am so happy to see those questions. It means that A, you understood what I was saying. B, you have huge capacity in the inventory space. You have great logic. You see straight to the point. There was no blah blah questions, not a single one. All of them were very, very smart, very, very powerful in terms of content, and very insightful in terms of the subject matter. So I'm very pleased we have at least 100 people who can think and operate at that level. I really want you to do the expert training. I really want you to become expert reviewers, because A, it will help you to understand much better the inventory realm, and B, you will help other people so much to do better in greenhouse gas mitigation, to do so much better with their inventories, to do so much better for our planet. So honestly, thank you so much for being who you are and what you are, for putting so much effort into your work and your research. My big respect to you.
Very, very motivational words. Thank you, Olia. And thank you everyone for joining, and I hope to see you all in the upcoming sessions, which you can register for online. And we will email out some of the resources that have been discussed. I see Sonero has put in the chat box the interpolation, extrapolation, and surrogate approaches chapter that Olia was talking about before. So thank you once again to Olia for speaking and to everyone for joining us. And for us, it's 11:30 p.m, so we will be going to bed. For everyone else, have a lovely day. Thank you. Bye.
Thank you. Bye-bye.